Hey math kids, today we're going to talk about particular values, and let's just start with some examples. You also might find this content on like other videos called initial conditions. It's all the same thing. Now we're given a derivative, and what we're going to do is we're going to take the antiderivative of that derivative to find out some stuff about the original function. So we're interested in f of x, and so we take the antiderivative of the derivative. So we raise that, divide, raise that, divide, and we get that. And then remember that's plus c. And this is equal to f of x. Now we would have to stop there, but we were given a particular value. So to do that, to use that, we're going to plug in 0 for x and 2 for y. So we get 2 is equal to 0 to the 4th over 4 minus 2/3 times 0 plus 3 times 0 plus c. So that cancels because it's all 0. That cancels, it's all 0. That cancels. So we get 2 equals c. So all we need to do now is erase this c and replace it with the value for c in 2, and then that is the actual function for f of x. Okay, let's try another one. So we're given a different derivative, 2 sine x minus the square root of x, and then f of 0 is equal to 4. Okay, so I'm going to rewrite the derivative before I take the antiderivative. Like that. Hopefully you're pretty comfortable doing that by now. Okay. Now we need to take the antiderivative. So sine normally goes to positive cosine, but since we're going backwards now, because it's antiderivative, it's going to be negative 2 cosine x. And then for a polynomial piece, we raise by 1, so x is 3 halves, or x to the 3 halves, and then we divide or multiply by the reciprocal. Okay? And we have our plus c, and then this is equal to f of x. And so now we plug in our particular value, and if we plug in 0 for the x's, and 4 for our y value. Now cosine of 0 is 1 if we think of the graph. So at 0, the y value is 1. So we get negative 2 times 1. This all goes to 0. So that's plus c, and that's 4. Okay, bring this over here. We get 4 is equal to, multiply those together, negative 2 plus c. So if we just add 2 to both sides, we see that c is equal to 6. And so we come back over here, erase that c, and then change it to a 6. And that's our answer. Okay, I'm going to keep going. Need some more room though. Okay. So this time we're given a second derivative. And then we're given initial conditions or particular values for the first derivative as well as for the original function, f. Okay, so we're basically going to go through the process 2 whole times. So we take the antiderivative of the second derivative, raise that by 1. 12 divided by 3 is going to be 4. Then we end up with that. So remember, this is our first derivative now. And we have our plus c. All right. Now we're going to use this. So we plug in 0 for x and negative 1 for y. That's 0, that's 0. So c is equal to negative 1. And so we get 4x cubed minus 4x minus 1. And that's the full derivative function. Okay. Now we need to get all the way down to f of x. So now we're going to take the antiderivative of that. So we raise it to a 4, x to the 4th. 4 divided by 4 just cancels, goes away. This is going to be x squared. Divide negative 4 by 2. We get negative 2. And then this is minus x. And then we have our plus c. This is our f of x function for now. We need to find our c, so we're going to use this. So the function equals 4 when x equals 1. Okay, we simplify, so 1 to the 4th is 1. 1 squared is also 1. 1 times negative 2 is negative 2. And then we have 1 minus 2 is negative 1. Negative 1 minus 1 is negative 2. And then we add 2 to both sides, and c equals 6. Okay? And this c goes in here. And so if you want, you can just erase that and change it to a 6. And that is our final answer right there. If you need additional help, please come to Math Lab. Until then, calculator.